In section 6.1, number 69, our directions are to find the inverse of this function, then prove by composition that the inverse is correct. And we need to check our domain. So remember, the first step of checking, of writing the inverse is to check that it's 1-to-1. And if it's not 1-to-1, we'll need to restrict the domain. So is this 1-to-1? This is kind of like think about that family of the x cubed family. It looks kind of like that. So that actually is a 1-to-1 function, so we don't have to worry about restricting the domain on that one. And then the second step is to rewrite this, rewrite the function notation as just x and y. So rewrite f of x or g of x or whatever it's called as a y. So I'm going to write y equals x cubed plus 3. Okay, and the third step is to now solve for, switch the x and the y. So you're going to rewrite it, and this is where they're going to do primes or draw a line to remind myself that I've already changed it, because else I think it gets confusing with the x's and y's that mean different things. So I'm going to write in this green box that I'm now doing the inverse. So after I've switched the x and the y's, this is now an inverse function. Even though it's not solved yet, it's still an inverse function, because I'm actually changing the values of x and y right now. So that's why I want to make a note to myself that I've changed what x and y mean by doing that switch. Okay, and now to put this into our typical notation, we will solve for y. So I get y cubed. I'm going to subtract 3 from both sides. And then I have y isolated, and then I'm just going to get y with no cubes, so I'm going to take the cubed root of both sides, and I get y equals the cubed root of x minus 3. And just to get that in more traditional format, whoops, that was step 4, not 5. We'll go to 5 as rewrite in that function notation with the inverse. So I'm going to put the y on the left to be more traditional. And that equals replacing y with the inverse, the function notation of it. And then x minus 3. And there's my inverse. Now the next task is, so I'm going to do my green box. So I know this is my inverse function. Everything in there is a little bit different. And then I want to check, in fact, let's call this function g of x. Let's call the inverse function g of x, so that way I can do my composition. I'm just going to give myself a little more space. So I can do g composed with f of x, and I want to see that those equal x, and I also want to do f composed with g of x. We'll get x. So I want to make sure that g can undo f and f undoes g. So both of those I will get x back. So starting with the g of f, so g of f of x equals, so g is this guy. So we have the cubed root of, instead of x, I'm going to write the f of x. So I'm just replacing that x with f of x. So instead of f of x, I can go see what f of x is, and I get this value. So I'm going to write x cubed plus 3. And then I can move those parentheses around because addition is associative, so I can switch it around. And I get the cubed root of positive 3 minus 3 cancels each other. So I can write x cubed plus 3 minus 3. And just moving those parentheses gives me cubed root of x cubed, which is x. So half done. Now I got to do the other composition. So this time I'm going to put g of x on the inside and evaluate it in f of x. So f of g of x is this guy rewritten, but instead of x, I'll write whatever g of x is. And g of x is cubed root, well, let's leave a little space for it. So I'm going to replace the g of x's with the cubed root of x minus 3. And putting that into f of x gives me this guy cubed plus 3. So the first thing I see is the cubed root cubed. Means that I just get rid of that cubed root and I'm left with what's inside, which is x minus 3. And then adding that plus 3. And I can move my parentheses again, so I get x minus 3 plus 3. I can just move those parentheses. And then I have a plus and negative 3, which gives me x plus 0, which is x. So there's my inverse and the proof of both. You got to check it both ways.